Welcome all of you to this video. In our previous video, we have learned to map our surrounding places. In this video, we will learn about polyhedron and its features. What do you understand by polyhedron? The groups of polygons that are joined to each other at the edges are called polyhedron. Each plane of a polyhedron is called a face. Can you tell the edges and the vertices of this polyhedron? Perfect. The edges are where the faces meet, and the points where the edges meet are called vertices. Let us now find the relation between the faces, edges, and vertices of a polyhedron with the help of an example. The teacher is conducting an activity for the children of class 8. She gives these polyhedrons to Raju, Monu, and Payal respectively. The number of faces, edges, and vertices are shown with F, E, and V respectively. Can you help Raju, Monu, and Payal fill this table? We start with the cube. As we can see, the cube has 6 faces, 12 edges, and 8 vertices. The sum of F and V is 14, and the sum of the edges and 2 is also 14. Let us now look at the octahedron. As we can see, the octahedron has 8 faces, 12 edges, and 6 vertices. Here also, we can see that the sum of F and V is 14, and the sum of E and 2 is also 14. Now, let's help Payal. As we can see, the pyramid has 4 faces, 6 edges, and 4 vertices. The sum of F and V is 8. The sum of E and 2 is also 8. Can you see any similarities? Well done. Here the sum of F and V and the sum of E and 2 is equal. This is true for all polyhedrons, which we call the Euler's formula, which is valid for all polyhedrons. You can check the Euler's formula by trying for other polyhedrons yourself. Now, let's learn about different types of polyhedrons. Do you remember convex and concave polygons? Based on this, can you tell whether the figure shown is a convex polyhedron or a concave polyhedron? Perfect. Since the line segments connecting any points inside this shape may also be outside the shape. Therefore, it is a concave polyhedron. Let us now discuss regular polyhedrons. If in a polyhedron all faces are congruent and regular, if the number of faces meeting on each vertex is equal, then the polyhedron is called a regular polyhedron. Now the question is the shown figure a regular polyhedron? As we can see that all the faces of the shape are congruent but not equilateral. Is the number of faces at each vertex equal? No. Let's see how. Number of faces on P equals 6. 3 faces forward and 3 faces backwards. Number of faces on Q equals 3. The number of faces on the vertices is not equal and the faces are not congruent. Therefore, this shape is not a regular polyhedron. Today, in this video, we learned features of polyhedron, Euler's formula. In the next video, we will understand some specific polyhedron prisms and pyramids. Welcome all of you to this video. We have understood the polyhedron and its properties in our previous video. In this video, we will understand some characteristics of polyhedron prisms and pyramids. Most people think of a prism. It looks something like this, but they do not know the exact definition of this. So let's start with the definition of prism. Prism is a 3D, means three-dimensional shape, whose base and upper end are congruent and parallel, and all side faces are parallelograms. Let's look at some of the shapes and understand prisms. Look at this three-dimensional shape here. Some lines are dotted here. These are lines that cannot be seen from this view. Look at the base and the top end of this shape. It is a long figure with base and upper ends. Now, let's give the base and top end of it a color like this. We can see that both the ends of this shape are triangles and its three side faces are rectangular, one in front, one at back, and one down. Let's look at the definition of prism once again. This says that the base and the upper end are congruent and parallel. The base and upper end of this shape are congruent and are parallel. Also, by definition, we know that all side faces are parallelograms. Side faces in this figure are parallelograms. That's why it is a triangular prism. Here is another three-dimensional shape. We can see that its base and upper ends are both rectangles, which are parallel to each other, and all its side faces are rectangles. This is called a rectangular prism. We also know it by the name of cuboid. If you notice, you will see that the prisms are named according to their base and upper end. As its ends are triangular, so it is a triangular prism. Its ends are rectangles, so it is a rectangular prism. Its ends are pentagon, therefore it is a pentagonal prism. Similarly, you can also identify the name of the prism according to the base and upper end of a prism. Is cylinder a prism? Let us discuss this. Its base and upper ends are circles and parallel to each other, but the ends of the cylinder are curved, that is, it is not a parallelogram. Therefore, it is not a prism. Now let's talk about the pyramid. What is a pyramid? On hearing the pyramid, one would probably remember the Pyramid of Egypt. But this is not the only type of pyramid. The Egyptian pyramids look something like this. It has 4 points, which we will write as A, B, C, and D. This solid has only one base, which is a triangle. It has 3 faces and all 3 are triangles. One on right, one left, and one back. It is a triangular pyramid because its base is a triangle. Here is another solid figure whose base is a square and all other faces are triangles. Can you see that there is a triangle on each side of the square? This solid is a square pyramid because its base is a square. So, how can we define a pyramid now? The pyramid is a solid figure with a polygonal base, and all other faces are triangles. Pyramids are classified according to their base. Remember that all the faces in a pyramid are triangles except the base. Today in this video, we learned to identify prism and pyramids. In the next video, we will see some examples based on them. Welcome all of you to this video. In the previous video, we studied the polyhedron and its properties. Today, we will see examples based on polyhedron. Mohini bought 2 boxes to keep her pencils from the market. Are both these boxes polyhedrons? As you can see, this box has curved edges. This box is not a polyhedron because its faces are not made up of a combination of flat polygons. Now, look at this second box. Is this a polyhedron? This box is made up of a combination of flat polygons. So, it is a polyhedron. But what kind of polyhedron is it? It has 9 faces, 14 vertices, and 21 edges. If we look closely, we will find that its base and end are made of congruent heptagons which are also parallel, and all lateral faces are rectangular. This polyhedron is an heptagonal prism. Let us now see another example. If a polyhedron has 12 vertices and 20 edges, can you tell the number of faces? Pause the video and try it yourself. Do you remember the formula that shows the relationship between the number of faces, edges, and vertices of a polyhedron? Perfect! In the previous video, we learned about the Euler's formula for polyhedrons. Here, the number of vertices V is 12 and the number of edges E is 20, and we have to find the value of F, the number of faces. By substituting the values of V and E in the Euler's formula, we get 10 as the value of F. So there are 10 faces in the polyhedron. Now, try to make such polyhedron by straws. In this video today, we saw an example based on the Euler's formula of polyhedron.